Have you ever stood under the quiet canopy of a clear night sky, feeling the gentle breeze against your skin, and wondered just how far that impenetrable silence truly stretches? It is a profoundly human experience to look up into the vast darkness and feel a sudden, overwhelming sense of smallness, a quiet realization that our everyday concerns are unfolding on a tiny stage suspended in an infinite arena. We move through our daily lives, walking down familiar streets, talking to familiar people, anchored to a planet that feels immense and unyielding beneath our feet. Yet, when we confront the cosmos, our perception of reality is gently but firmly challenged. The universe holds mysteries that defy our most basic intuitions about size, space, and the nature of existence itself. We are comfortable with the scale of mountains, oceans, and continents, but the cosmos invites us on a journey that requires us to leave those comforting metrics behind. Let us begin this journey by looking at our own cosmic neighborhood, a place that is already so large that the human mind struggles to contain it. Our home, the Milky Way, is what scientists call a barred spiral galaxy, a beautiful, swirling structure of ancient stars, glowing gas, and dark dust, all dancing around a central bulge where an enormous black hole waits in the dark. From one edge to the other, our galaxy measures roughly 100,000 light-years across. To truly appreciate this number, you must abandon your earthly sense of speed. If you could somehow travel at the speed of light, racing through the void, faster than anything else allowed by the laws of physics, it would still take you 100,000 years to cross from one side of our galactic home to the other. 100,000 years is a span of time longer than modern humans have existed, longer than the time since we first learned to paint our dreams on the cold walls of caves, and longer than every civilization that has ever risen and fallen on Earth combined. Within this swirling city of light, there are somewhere between 200 billion and 400 billion stars. Each of those glowing embers might have quiet planets orbiting around them, moons circling those planets, ancient asteroids tumbling through the cold space, and comets streaking across the eternal night. Our sun is just one of those hundreds of billions of stars sitting in a quiet neighborhood called the Orion Arm, about 26,000 light-years from the bustling galactic center. As we sit here, seemingly still and at peace, our sun and its family of planets are actually hurtling around the center of the galaxy at a staggering speed of about 500,000 miles per hour, even moving at that tremendous velocity. The journey is so unimaginably long that it takes our solar system about 250 million years to complete a single lap around the galactic center. Astronomers sometimes call this vast period a cosmic year, or a galactic year. Think about the profound depth of that time. In the entire time the dinosaurs roamed the Earth, dominating the land with their heavy steps, our solar system did not even complete one full orbit. The last time our sun was in roughly this current position in the galaxy, the most complex life on our planet consisted of simple marine organisms floating in primordial seas. This is the scale of the mystery we are trying to comprehend, a scale that generates a sense of respectful awe and gentle humility. Yet, despite the billions of stars, the space between them is characterized by an almost unimaginable emptiness. Our nearest stellar neighbor, a small red dwarf called Proxima Centauri, is about 4.24 light-years away. That distance is so profoundly great that if you were to shrink our life, giving sun down to the size of a single grain of sand, Proxima Centauri would be just another grain of sand sitting about 4 miles away. The space in between these two tiny grains would be essentially void, containing nothing but the faintest whiff of gas and dust and the occasional wandering particle of cosmic radiation. We are so accustomed to a crowded planet, surrounded by billions of other people and an abundance of life, that this deep, quiet emptiness is hard to wrap our minds around. But in the cosmos, emptiness is the rule, and stars are separated by such vast gulfs that the chance of any two of them colliding by accident is essentially zero. Entire galaxies can pass right through each other like ghosts, their stars weaving through the empty spaces without ever actually touching. When you look up at the night sky from a truly dark location, away from the glaring lights of our cities, you might notice a hazy band of light stretching across the heavens. This pale glow is actually the combined light of billions upon billions of distant stars in our own galaxy. Ancient people looked at this delicate ribbon of light and thought it looked like spilled milk across the heavens, which is how we inherited the beautiful name Milky Way. For most of human history, as we gazed up in wonder, we assumed that this band of light was everything that existed, believing our galaxy was the entire universe. But the universe is always ready to expand our understanding if we are willing to look deeper. In the 1920s, the universe grew infinitely larger in our minds when an astronomer named Edwin Hubble, using a telescope with a mirror 100 inches across at the Mount Wilson Observatory in California, made a discovery that shattered our cosmic isolation. He proved that the fuzzy smudges people had been seeing through telescopes were not just clouds of gas within our own galaxy, but entire galaxies themselves, each containing billions of their own stars, sitting impossibly far away in the deep silence of space. He observed a class of stars called Cepheid variables in the Andromeda Nebula, and his calculations revealed a shocking truth. Andromeda was not a cloud within our home. It was roughly 1 million light-years away, an entirely separate island universe of stars. We now know that Andromeda is actually about 2 million light-years away. But the realization was permanent. Our galaxy is not the whole cosmos, but just one, among an unfathomable multitude. Today, we estimate with quiet astonishment that there are around 2 trillion galaxies in the observable universe. 2 trillion is a number so vast, a 2 followed by 12 zeros, that it stops carrying meaning for our human brains and becomes a symbol of the infinite. Yet, in this ocean of 2 trillion galaxies, not all are created equal. Some are tiny, ancient dwarf galaxies containing just a few billion stars, while others are massive spirals like our Milky Way or our neighbor Andromeda. But hiding in the deep cosmic night, sitting at the extreme end of the scale, there are true monsters of the universe. Galaxies so enormous that they make our massive Milky Way look like nothing more than a fragile speck of dust floating in a vast, empty warehouse. We are about to embark on a journey to meet one of these giants, a galaxy so immense it challenges the very limits of what we thought the universe could build. This quiet behemoth waits for us in the distant dark, 1 billion light-years away, holding secrets about the past, the future, and the deepest mysteries of the cosmos. To fully embrace the scale of what we are about to discover, we must first understand how the universe organizes its boundless energy and matter. Galaxies, those magnificent islands of ancient light, come in many shapes and sizes, each telling a different story of cosmic evolution. The most common type in the nearby universe are spiral galaxies just like our own, adorned with their distinctive, graceful pinwheel arms and flat rotating disks. These sweeping structures are places of vibrant creation, active sites where new stars are continuously being born within the gas-rich spiral arms. The beautiful, fragile structure we observe is maintained by a delicate cosmic balance between the rotational motion of the disk and the persistent gravitational pull of all the matter held within. But the universe is also populated by elliptical galaxies, which present a stark contrast to the swirling spirals. Unlike the spirals, these galaxies have no particular structure, ranging from nearly spherical shapes to highly elongated ovals, and they are populated mainly by old, red stars that have been burning quietly for eons. In these quiet, smooth galaxies, star formation has largely ceased, as they have long exhausted most of their precious gas supply. The largest galaxies in the entire universe are almost exclusively elliptical, majestic structures formed through the slow, inevitable merger of multiple smaller galaxies over billions of years of cosmic history. Galaxies, we have learned, do not wander the infinite void in complete isolation. They are intricately organized into larger, majestic structures. There are galaxy groups, which contain a handful to a few dozen galaxies. Our own Milky Way, for instance, belongs to a gentle gathering known as the Local Group, which contains about 80 known galaxies, including Andromeda, and several dozen tiny dwarf galaxies. Beyond these intimate groups are the galaxy clusters, larger still, containing hundreds to thousands of galaxies all bound together by the invisible, unyielding thread of gravity. And reaching the very pinnacle of cosmic architecture are the superclusters, vast and sweeping assemblages of galaxy clusters stretching across hundreds of millions of light years of the dark void. It is within one of these massive clusters that our destination lies. The galaxy we are traveling toward is one of those true monsters, going by the somewhat clinical and boring name of IC 1101. This name simply comes from its entry number in a catalog of celestial objects created over a century ago. But you must not let the dull name fool your sense of wonder. There is absolutely nothing boring about this ancient cosmic giant. IC 1101 sits patiently at the very center of a massive cluster of galaxies called Abel 2029, located far away in the direction of the constellation Virgo, as seen from our fragile Earth. When astronomers point their powerful telescopes toward this deeply quiet region of the sky, they see a massive, majestic collection of galaxies, all bound together by gravity, performing an eternal dance around a common center. And right there, resting in the absolute heart of that cluster, dominating everything around it, like a cosmic emperor sitting silently on a dark throne, is IC 1101. This gentle behemoth is estimated to be somewhere around 4 to 6 million light years across. Let that measurement sink deeply into your mind for a moment of quiet reflection. Our Milky Way, which we already established seemed impossibly large, is only about 100,000 light years wide. This means that IC 1101 is roughly 40 to 60 times larger than our entire sprawling home galaxy. If you were to gently place IC 1101 right where our Milky Way currently sits in the dark, it would not just engulf our galaxy. It would swallow our entire cosmic neighborhood without a trace. The great Andromeda galaxy, sitting about 2.5 million light years away from us, would suddenly find itself deep inside the massive body of IC 1101. The Triangulum galaxy, another close neighbor of ours, would also be instantly consumed. All of the dozens of smaller dwarf galaxies that orbit patiently around us, familiar places like the Large Magellanic Cloud and the Small Magellanic Cloud, would simply become tiny, insignificant components of this giant's vast and ancient structure. As we step forward into the silence of this narrative, we carry with us an open mind and a peaceful heart, ready to understand the beautiful tension between what we know and the vast unknown that awaits us. But physical size is just the very beginning of what makes IC 1101 so incredibly breathtaking to contemplate. This ancient galaxy is estimated by our astronomers to contain around 100 trillion stars. 100 trillion. To find a place for this number in your mind, remember that our Milky Way has maybe 400 billion stars at its absolute most. That simple comparison means that IC 1101 has roughly 250 times more stars than our peaceful home galaxy. If you were to sit under the night sky and start counting the stars in IC 1101, naming just one star per second without ever stopping, it would take you over 3 million years just to count to 100 trillion. And that is assuming a journey where you never slept, never stopped to eat, and never took a break of any kind from your quiet counting. Imagine that infinite span of time, 3 million years of unbroken silence, simply acknowledging the existence of each glowing ember in a single distant galaxy. It is a profound mystery how such a magnificent collection of matter can exist in the gentle stillness of the deep universe, undisturbed by the fleeting passage of human generations. The story of how our curious species discovered this cosmic giant begins back in the year 1790, when a German-born British astronomer named William Herschel was systematically scanning the vast night sky with his telescope. Herschel was one of the greatest explorers of his era, a man driven by a deep sense of wonder about the cosmos. He had already discovered the planet Uranus several years earlier, and he spent much of his quiet life carefully cataloging thousands of celestial objects that no human eyes had ever documented before. On June 19th of that year, Herschel pointed his brass and glass instrument toward a dark region of the sky in the constellation Virgo and noticed a faint, fuzzy blob of light. He carefully recorded its position in the heavens and moved on to the next object, entirely unaware of the magnificent monster he had just brushed against with his sight. At the time, Herschel had absolutely no way of knowing what he was actually looking at in the silence of his observatory. The technology simply did not exist to measure how far away this gentle, glowing object was. The scientific understanding of the era did not exist to recognize that it was an entire galaxy, completely separate from our own. Herschel simply logged it as another nebula, one of many mysterious cloud-like objects scattered across the infinite heavens. For over a century, that faint smudge of ancient light remained a quiet mystery, a secret kept safely by the universe. It was eventually given the designation IC 1101 when it was included in a catalog called the Index Catalog, which was a vast expansion of an earlier list of celestial objects. Astronomers studied it when they could, peering through the darkness, but without the proper tools to understand its true, monumental nature. It remained just another numerical entry in a long list of cosmic curiosities. Everything changed in the 20th century when humanity developed better, more sensitive telescopes and entirely new techniques for measuring the seemingly infinite cosmic distances. They discovered with profound awe that IC 1101 was not merely a cloud of gas resting within our own galaxy. It was an entirely separate island of stars, mind-bogglingly far away in the deep cosmos. The gentle light we see from IC 1101 today actually left that galaxy over 1 billion years ago. It has been traveling through the endless, freezing void of space for more than 1 billion years, just to reach our fragile telescopes. When that light first began its long, quiet journey toward us, the spark of life on Earth was still mostly confined to simple, single-celled organisms floating in primordial waters. Complex animals had not yet evolved to wander the land. The heavy, thundering dinosaurs would not appear on our world for another several 100 million years. Every major event in human history, from the rising of the first ancient civilizations along mighty rivers to the very invention of the telescope itself, happened while that ancient light was still crossing the vast emptiness between the distant galaxies. It is deeply humbling to look at a photograph of this galaxy and realize you are staring into a past so deep it predates the continents as we know them. As astronomers continued their quiet journey of observation, looking ever deeper at IC 1101, they began to unravel the mystery of why it was so incredibly massive. They realized that this galaxy did not grow to its enormous, terrifying size through normal, peaceful processes alone. It became a giant through an act of cosmic violence that has been unfolding in the silence of space for billions of years. IC 1101 is what scientists call a cannibal galaxy, an ancient predator that has been slowly eating other galaxies. To truly understand galactic cannibalism, we must think about how the gentle but relentless force of gravity works on the largest scales of the universe. Galaxies, as we have discovered, do not exist in complete isolation from one another. They are grouped together in vast clusters, held tightly by their mutual gravitational attraction. Within these massive clusters, galaxies perform a slow, majestic dance around each other, sometimes passing incredibly close by, and sometimes colliding directly in the dark. When two galaxies get close to each other, their immense gravity begins to distort their shapes, stretching them across the void. Stars get gently pulled out of their normal, ancient orbits. Clouds of gas and dust get compressed and stretched into long glowing ribbons. If the interacting galaxies are similar in size, they might gracefully merge together over hundreds of millions of years, eventually calming down to form a single, larger galaxy. But if one galaxy is much bigger than the other, something entirely different happens in the quiet dark. The larger galaxy simply absorbs the smaller one, stripping away its stars and its gas, and adding all of that scattered material to its own massive body. This slow, inevitable consumption is exactly what has been happening to IC 1101 for billions of years. As the absolute largest and most massive galaxy sitting in its cluster, IC 1101 rests firmly at the gravitational center of everything around it. Smaller, wandering galaxies that venture too close to this center get hopelessly trapped by its enormous, unyielding gravity. They begin a slow, infinite spiral inward, getting torn apart and consumed over millions of years of silent destruction. Each cosmic meal makes IC 1101 just a little bit bigger, a little bit more massive, and a little bit more dominant over its domain. Scientists who study this gentle monster estimate that IC 1101 has undergone at least 76 major mergers over its long, ancient history. 76 separate times, another substantial star-filled galaxy fell into this cosmic giant and was absorbed completely into its vast body. And those are merely the major mergers we can detect. Countless smaller dwarf galaxies have also been consumed over the eons, galaxies so small that they barely registered as a meal for this enormous ancient predator. The undeniable evidence for this cannibalistic history is beautifully and tragically written in IC 1101's very structure. When you look at a vibrant galaxy like our Milky Way, you see a beautiful, spinning spiral pattern. Those graceful spiral arms are energetic regions where stars are actively forming, where vast cold clouds of gas are gently collapsing under gravity to create brilliant new stellar nurseries. Spiral galaxies possess lots of gas and dust, the essential raw materials needed for star formation, and they maintain a distinct, beautifully rotating disk shape. But IC 1101 looks absolutely nothing like this familiar shape. It is what astronomers call an elliptical galaxy, which means it has a smooth, featureless, oval-shaped appearance with no spiral arms at all. Elliptical galaxies are born when spiral galaxies collide and merge together. The violent, chaotic gravitational interactions during a massive merger completely destroy the delicate, sweeping spiral structure, mixing all the ancient stars together into a more random, spherical, or oval distribution. The very fact that IC 1101 is such an enormous elliptical galaxy tells us without a doubt that it has experienced so many collisions that any original beautiful spiral structure it might have once possessed has been completely erased from existence. All of those slow collisions, all of that endless gravitational chaos spanning billions of years, has stirred up the trillions of stars like someone slowly mixing ingredients in a dark cosmic bowl. What remains today is this smooth, featureless giant, a quiet monument and a testament to billions of years of galactic consumption in the deep silence of the universe. This quiet realization brings a profound sense of humility to anyone seeking to understand our place in the cosmos. We are so accustomed to thinking of the universe as a peaceful, unchanging tapestry of light. But the reality is an endless cycle of slow, majestic transformation that operates on scales far beyond our daily worries. Our intellectual journey into the heart of this giant is far from over, and the deeper we look into its ancient core, the more terrifying and magnificent its secrets become. But there is something even more remarkable and perhaps deeply melancholic about IC 1101. Despite containing an unfathomable 100 trillion stars, this majestic cosmic island is actually a dying galaxy. When astronomers peer into its depths, they find that the stars within it are almost all unimaginably old. Most of them are what scientists quietly call red giants or yellow stars, ancient stellar objects that have already burned bravely through most of their precious nuclear fuel over billions of years. Very few new stars, if any, are being born inside the vast expanse of IC 1101. This gentle silence of creation might seem strange at first when you consider its colossal mass. With so many trillions of stars and so much gravity, you might expect this galaxy to be a vibrant hotbed of stellar activity. But we must remember how this ancient predator grew so large in the dark. Every single time it consumed another wandering galaxy, it also greedily consumed that smaller galaxy's delicate gas supply. Gas is the fundamental fuel for star formation, the cosmic clay from which new light is molded. Without this drifting gas, new stars simply cannot be born into the night. Over billions of years of relentless cannibalism, IC 1101 has either used up or violently expelled almost all of its available gas. The immense mergers themselves were often violent enough to heat the delicate gas to extreme, searing temperatures, causing it to rapidly expand and escape the galaxy's gravitational grip entirely. Or the crushing gravity compressed the gas so quickly that it all formed into stars at once in brief bursts of blinding activity. Either way, the final result is an ancient galaxy that has completely run out of the raw materials needed to create new light. What remains now is a quiet giant slowly fading into the eternal cosmic night. The trillions of stars that exist there right now will bravely continue to shine for billions of years to come. But as they eventually exhaust their fuel and quietly die, there will be no new generations of stars to replace them. IC 1101 is like a magnificent kingdom that has conquered all of its surrounding neighbors, but sadly has no children left to carry on its monumental legacy. It is massive, immensely powerful, and utterly magnificent to behold. Yet, it is also approaching the end of its active life, a fading monument in the cosmic silence. As we drift further inward on our contemplative journey, seeking the very heart of IC 1101, we encounter a mystery even more profound than the galaxy itself. Sitting in complete silence at the absolute center of this cosmic giant is one of the largest known supermassive black holes in the entire universe. Our scientific understanding tells us that every large galaxy gently cradles a supermassive black hole at its core. Our own quiet Milky Way has one named Sagittarius A star, which contains roughly 4 million times the mass of our life-giving sun. The black hole resting at the center of the neighboring Andromeda galaxy is significantly bigger, containing somewhere around 100 million to 200 million solar masses. But the dark entity waiting at the center of IC 1101 belongs to a completely different category of existence. Astronomers carefully estimate that it contains somewhere between 40 billion and 100 billion times the mass of our Sun. Let us pause for a moment to let that unimaginable scale settle into our minds. To place this ancient monster into a perspective we can almost grasp, this single black hole might possess 25,000 times more mass than the black hole sitting at the center of our entire Milky Way galaxy. Let me gently guide you toward understanding just how massive this object truly is. If you could somehow find a cosmic scale to weigh our entire Earth, you would find it has a mass of roughly 6 trillion kilograms. That number sounds like an absolute infinity until you compare it to our Sun, which is about 330,000 times more massive than the Earth. Our Sun is a fairly ordinary star by the sweeping standards of the cosmos. Now, take that Sun, the very anchor of our existence, and multiply its mass by an astonishing 50 billion. That incomprehensible number is roughly how much mass is packed into the supermassive black hole hiding at the center of IC 1101. All of that incomprehensible mass is completely compressed into a region from which nothing can escape. The gravitational pull at the event horizon, which is the terrifying boundary of the black hole, is so intensely profound that even light itself cannot break free from its grasp. The physical size of a black hole's event horizon depends entirely on its accumulated mass. For a supermassive black hole containing 50 billion solar masses, scientists calculate that the event horizon would have a radius of roughly 150 billion kilometers. That number might simply sound enormous, and it truly is, but we must gently remember that this is a region containing 50 billion times the mass of the Sun, all compressed into what is essentially an infinitely small point at the very center. The event horizon is merely the dark boundary line, the point of no return beyond which escape becomes a physical impossibility. To put this terrifying boundary into perspective, our entire solar system, stretching from the warm Sun all the way out to the freezing orbit of Neptune, is about 9 billion kilometers across. The silent event horizon of IC 1101's black hole is roughly 16 times larger than our entire solar system. If you were to gently place this ancient black hole where our sun currently sits, its event horizon would effortlessly extend well beyond the distant orbit of Pluto, silently engulfing absolutely everything we consider our cosmic home. What would it actually be like to drift near this monstrous silent black hole in the dark? The physics of such extreme environments is entirely bizarre and deeply counterintuitive to our earthly senses. Time itself would begin to pass differently near the edge of the event horizon compared to a safe distance far away. A brave observer falling slowly toward the black hole would look back and see the outside universe seemingly speed up. Meanwhile, a quiet observer safely on the outside would see the falling person progressively slow down, appearing to completely freeze in time as they approach the absolute horizon. From the outside perspective, the falling traveler would never seem to actually cross that final, dark boundary. Inside the event horizon, space and time themselves become so aggressively warped and twisted that the very concept of escaping becomes utterly meaningless. The central singularity, a theoretical point of infinite density, would gently but relentlessly tear apart absolutely anything that fell into its grasp, stretching it into long, incredibly thin strands through a terrifying process physicists have nicknamed spaghettification. But here is something profoundly remarkable and unexpectedly peaceful about this terrifying cosmic entity. Despite its enormous size and its terrifying physical properties, the supermassive black hole at the center of IC 1101 is currently existing in a state of relative quiet. It is not actively devouring huge amounts of matter in a frenzy. There is no brilliant, swirling accretion disk of superheated gas screaming around it, lighting up the darkness. There is no powerful jet of raw energy shooting out into intergalactic space at nearly the speed of light. The black hole is simply there, waiting silently in the dark, because it has already patiently consumed most of the material that was easily within its vast reach. This gentle quietness is actually intimately related to the exact same phenomenon that has stopped the galaxy of IC 1101 from forming any new stars. Most of the drifting gas in the galaxy has already been used up or blown away, and without a fresh supply of gas falling inward toward the center, the great black hole has very little to eat. Occasionally, an unlucky ancient star might wander just a little too close and get violently torn apart, providing a brief, fleeting meal that gently illuminates the deep dark. But these events are exceedingly rare in the modern era. The supermassive black hole, much like the giant aging galaxy that hosts it, is a magnificent giant in repose, immensely powerful but deeply dormant, dreaming peacefully in the cosmic night. This gentle slumber invites us to reflect on the nature of power and stillness, reminding us that even the most destructive forces in the universe eventually find their way to a quiet, enduring calm. Yet, even in this profound and peaceful slumber, there are still lingering traces, ancient ghostly echoes of the black hole's distant, violent past. Astronomers peering into the deep radio frequencies have gently detected a persistent radio source right at the very center of IC 1101. A faint whisper catalogued meticulously as PKS 508 plus 059. This quiet radio emission does not come from stars, but from relativistic jets, which are unimaginably powerful streams of particles that were accelerated to nearly the speed of light and ejected from the immediate chaotic vicinity of the black hole long ago. These sweeping, majestic jets were originally powered by the black hole's terrifying rotation and its deeply tangled magnetic fields, and they had the raw power to carve out enormous, empty cavities in the surrounding sea of gas. When our modern scientists look at images carefully gathered by X-ray telescopes orbiting our Earth, they can see these ancient cavities quite clearly. They appear as massive, silent bubbles of very hot, very thin gas that have been blown outward into the dark by the sheer, staggering energy released near the hungry black hole. Some of these quiet bubbles are millions of light years across, standing as a silent, majestic testimony to ancient periods in the deep past, when the supermassive black hole was much more active and vibrant than it is in its current resting state today. The total energy required to inflate these colossal bubbles in the dark is truly staggering to contemplate, roughly equivalent to the total combined energy output of billions of stars shining brightly over millions of years. It is a gentle reminder that even the deepest silence we observe today was once filled with the roaring energies of creation and destruction, energies so vast they shaped the very structure of the cosmos we now admire. This intimate, powerful kind of feedback, this ancient conversation between supermassive black holes and the giant host galaxies that surround them, is currently one of the most exciting and active areas of research in all of modern astrophysics. Scientists now deeply believe that these supermassive black holes play an absolutely crucial guiding role in regulating both the growth and the slow evolution of the galaxies they inhabit. When immense rivers of cold gas flow inward toward a galaxy's center, gravity pulls it closer to the waiting dark, but the black hole, upon consuming some of this material, can suddenly release enough explosive energy to heat the remaining gas and violently push it outward, effectively preventing it from ever cooling enough to form new shining stars. This magnificent cosmic dance creates a kind of natural thermostat effect, a delicate balancing act that ultimately helps determine the final size, shape, and unique properties of the largest galaxies in the universe. In the specific case of the giant IC 1101, this ancient feedback mechanism may be partly, if not largely, responsible for the galaxy's current quiet state. The immense black hole has essentially helped to shut down all new star formation by repeatedly heating the surrounding gas, preventing it from cooling down and gently collapsing into stellar nurseries. Over billions of years, the giant galaxy and its deeply hidden giant black hole have slowly reached a kind of peaceful, enduring equilibrium. Each one has carefully shaped the other over countless eons of shared, silent evolution, a perfect partnership of gravity and energy that has resulted in the largest collection of stars we have ever witnessed. It is a beautiful paradox that the very engine of destruction at the heart of the galaxy is also the mechanism that ultimately brought it to a state of profound peace. But how did this central monster grow to contain 50 billion solar masses? Black holes, we must understand, grow primarily by consuming the matter that is unfortunate enough to fall into them. However, when entire galaxies merge together in the deep dark, the supermassive black holes resting at their respective centers eventually find each other and merge as well. Over the course of IC 1101's incredibly long history of galactic cannibalism, its central black hole has been fed again and again, not just with gas and dust, but with other black holes. Every single time that IC 1101 consumed another wandering galaxy, it also eagerly added to the mass of this growing monster at its core. Every merger brought in a fresh supply of raw fuel to satisfy the black hole's seemingly insatiable, ancient appetite. The slow, inevitable process by which two supermassive black holes eventually merge is both deeply fascinating and almost incomprehensibly violent. When two giant galaxies initially collide, their central black holes do not immediately find each other in the chaotic dark. They are initially separated by vast, sweeping distances and surrounded by billions of swirling stars. But as the magnificent merger slowly progresses over millions of years, gravitational friction with the surrounding sea of stars gradually causes the two black holes to begin a slow, deadly spiral toward the true center of the newly combined massive galaxy. They dance a slow waltz through the stars, drawn together by an irresistible, invisible force. Eventually, after an agonizingly long period of time, the two black holes get close enough to form a binary system, locked in a tight, inescapable orbit around each other. As they circle each other in the dark, they slowly lose energy through a profoundly mysterious phenomenon known as gravitational waves, which are actual physical ripples traveling through the very fabric of space-time itself. These invisible, ghostly waves carry tremendous energy away from the binary system, causing their mutual orbit to shrink ever so slightly with each passing moment. The two black holes spiral closer and closer together, orbiting faster and faster, whipping around each other at speeds approaching the speed of light, until finally they merge in a sudden, catastrophic event that releases truly enormous amounts of invisible energy into the void. When two supermassive black holes merge, the gravitational waves they produce are among the most unimaginably powerful events in the entire universe. The final, terrifying moment of merger releases more total energy than all the billions of stars in a typical galaxy combined, although almost all of this staggering energy is released purely in the form of gravitational waves, rather than visible light. These ancient waves gently ripple outward at the speed of light, literally stretching and squeezing the very space itself as they pass by. For most of human history, these ripples passed through our bodies and our planet completely unnoticed. We have only very recently, as a curious species, developed the sophisticated technology required to detect these quiet whispers of gravity. The very first direct detection came in the year 2015, when the magnificent LIGO observatories successfully measured the gentle waves from two smaller stellar mass black holes merging about 1 billion light-years away in the deep cosmos. Since that momentous historical discovery, dozens of separate gravitational wave events have been carefully observed by our scientists, quietly opening up an entirely new, deeply profound way of studying the hidden universe. Future gravitational wave detectors, like the highly anticipated planned LISA mission that will eventually fly in the silence of space, will be sensitive enough to detect the monumental mergers of supermassive black holes. When the LISA observatory finally launches, perhaps sometime in the 2030s, it might actually be able to detect massive events that are very similar to the ancient, violent mergers that slowly built up IC 1101's central black hole over the eons. We will be able to literally listen to the universe as giant black holes collide and merge in the dark, adding another profound sense to our growing astronomical toolkit. It is deeply moving to realize that IC 1101's black hole has experienced dozens of such dramatic mergers over its incredibly long, silent history. Each massive merger added new mass and fundamentally altered the growing black hole's spin. The chaotic process of multiple sequential mergers also deeply affected the surrounding galaxy itself, as the violently merging black holes frequently flung nearby stars outward through complex gravitational interactions. This ongoing gravitational scouring is probably exactly why IC 1101's immense core is so remarkably large. yet surprisingly faint for a galaxy of its staggering proportions. Repeated black hole mergers have systematically scattered billions of ancient stars away from the very center over billions of years, carefully creating a core profile that is highly unusual for galaxies of this magnificent size. As we gently contemplate these numbers, we are not just learning facts. We are expanding the very boundaries of our minds. We are learning to hold the infinite in our thoughts, to find peace in the realization that we are part of a universe capable of building such incomprehensible structures. The silence of that massive core, filled with trillions of old stars slowly fading into the night, is a beautiful reminder that even the most monumental creations in the cosmos eventually find a place of quiet rest. The immense black hole resting in its heart, holding 50 billion times the mass of our sun, is no longer a monster to fear, but a quiet guardian of galactic history. To truly anchor our minds in this quiet contemplation, I want to gently take you on a journey of scale, a mental expedition, to help you truly appreciate the physical magnitude of what we are discussing. Imagine, for a moment of quiet reflection, that you could somehow travel from one extreme end of IC 1101 to the other. You would need to bravely cross somewhere between 4 million and 6 million light years of empty, ancient space. Remember that light, the fastest messenger in our universe, travels at an incomprehensible speed of about 6 trillion miles per year. Even traveling at that ultimate, absolute speed limit of the cosmos, crossing the entire width of IC 1101, would still take you millions of years of uninterrupted journeying in the dark. But let us try another, more human comparison to foster our sense of wonder. Consider the brave Voyager 1 spacecraft, gently launched into the dark by NASA in the year 1977. It remains the fastest human-made object ever to leave the comforting warmth of our solar system. It is currently traveling at a speed of about 38,000 miles per hour relative to our Sun. At that staggering speed, Voyager 1 would still take about 80,000 years just to cross the relatively small gulf to reach the nearest star to our Sun, Proxima Centauri, which sits only about 4 light years away. To cross the entire span of our own Milky Way galaxy at Voyager, one's impressive speed would take about 2 billion years of silent travel. And to cross the majestic expanse of IC 1101, you would need somewhere between 80 billion and 120 billion years. That span of time is vastly more than the entire universe has even existed since the original spark of creation. Even with our fastest, most triumphant spacecraft, crossing this single, isolated galaxy would be completely impossible within the current age of reality. Here's another gentle way to think about it: to bring the cosmos down to a scale our minds can naturally touch. If you could somehow shrink the entirety of our beautiful Milky Way down to the familiar size of a dinner plate, sitting about 10 inches across on a quiet table, then IC 1101 would be the size of a large swimming pool. Our entire magnificent galaxy, with all of its hundreds of billions of stars and the delicate sweeping spiral arms where we make our peaceful home, would be nothing more than a tiny dish floating aimlessly in a vast, deep sea. Or consider the quiet, persistent journey of the light itself. The gentle light from IC 1101 has traveled for over 1 billion years just to reach us. In all that unfathomable time, light has been continuously streaming away from this ancient galaxy in absolutely every direction into the infinite void. Every single second, IC 1101 radiates enough brilliant light to travel about 186,000 miles. Over the course of 1 billion years, that light has traveled 1 billion light years, which is roughly 6 billion trillion miles of silent, dark space. And it is only now, at this very moment in history, just arriving at the delicate mirrors of our waiting telescopes, ancient photons that originally left their magnificent home galaxy when our own Earth was still struggling through its earlier stages of developing complex life. It is a profound mystery to realize that we are gazing at a ghost, a vision of the past that has crossed an ocean of time just to touch our eyes. The breathtaking discovery and the continuing quiet study of IC 1101 would have been absolutely impossible without the tremendous, sweeping advances in human telescope technology over the centuries. In the early, quiet days of astronomy, our view of the heavens was severely limited by the physical size of the glass lenses and metal mirrors we could craft with our simple hands. Larger telescopes could gather more ancient light and see much fainter objects hiding in the dark, but there were strict practical limits to how big you could build a telescope on the shifting ground. The Earth's atmosphere also posed a tremendous, frustrating problem for those seeking clarity in the night. Our atmosphere is constantly moving, shifting, and shimmering with thermal currents, which is precisely why the ancient stars appear to twinkle so beautifully to our observing eyes. This poetic twinkling, however, violently blurs the delicate images that our ground-based telescopes can capture, severely limiting how clearly they can see distant, subtle objects in the deep universe. For most of the 20th century, our dedicated astronomers could clearly see that IC 1101 existed and was very large, but they simply could not study its intricate, detailed structure through the shifting haze of our world. Everything changed profoundly with the triumphant launch of the magnificent Hubble Space Telescope in the year 1990. Floating gracefully in the silent void above the blurring atmosphere, Hubble could finally capture images of the deep cosmos with incredible, unprecedented clarity. Over the quiet decades since its launch, Hubble has observed IC 1101 multiple times, gently revealing intimate details about its massive core, its surrounding ghostly halo of stars, and its complex gravitational relationship to the other swirling galaxies trapped in its massive cluster. A comprehensive study conducted in 2017, using these precise images, measured the galactic core and found that it stretches across nearly 14,000 light years. That means just the central core of IC 1101 is bigger than most entire dwarf galaxies in the universe, containing more stars than most complete galaxies we know of. More recently, our scientists have carefully used a diverse variety of other powerful telescopes to study this giant at many different wavelengths of invisible light. Massive radio telescopes have successfully detected the faint emission from its central, sleeping black hole. Advanced X-ray telescopes, like the Chandra X-ray Observatory, have quietly observed the superheated gas that fills the vast cluster around it, while sensitive infrared telescopes, like Spitzer, have peered through the obscuring cosmic dust to gently study the older, cooler stellar populations residing within the galaxy itself. Modern ground-based observatories have also improved dramatically, using a brilliant technique called adaptive optics, which uses deformable mirrors and lasers to correct for atmospheric distortion in real time. The result is images that approach the stunning quality of space-based observations, but from telescopes that can be much larger than anything we could currently launch into orbit. The absolute largest ground-based telescopes today boast mirrors more than 30 feet across, gathering enormous amounts of ancient light and able to detect objects billions of times fainter than the unaided human eye can perceive. Even more powerful instruments are joining this grand pursuit. The James Webb Space Telescope, launched in late 2021, has already begun observing the distant, ancient galaxies with unprecedented sensitivity in infrared light, while the extremely large telescope, currently under construction in Chile, will feature a mirror nearly 130 feet across when it finally sees first light. Each new observation, each new technological marvel, adds another vital piece to our growing understanding of this cosmic giant, expanding the mystery even as it provides comforting answers to our questions. But to truly measure the vastness of the cosmos, we must ask how we determine the distance to an object we can never physically reach. Distance is one of the most fundamental quantities in astronomy, yet it is one of the hardest to confidently measure. For relatively nearby celestial objects, astronomers gently use a beautiful geometric technique called parallax. As our Earth peacefully orbits the Sun, our visual perspective on the nearby stars changes ever so slightly against the deep, distant background. By meticulously measuring how much a star appears to shift over the course of a year, astronomers can calculate how far away it is. This works beautifully for stars within a few thousand light years, but for more distant objects, the shift is too infinitesimally tiny to measure, even with our most precise instruments. For these more distant objects, astronomers rely on a concept called the cosmic distance ladder, a brilliant series of techniques that build upon each other. One rung of this delicate ladder involves a special type of star called a Cepheid variable, which pulsates in brightness in a highly regular rhythmic pattern. By measuring how bright a Cepheid appears and how fast it beats, astronomers can calculate its true distance across the dark. However, IC 1101 is so deeply distant that even these incredibly bright stars are completely invisible to us. For such extreme journeys across the void, astronomers must rely on even brighter standard candles, specifically a type of exploding star called a Type Ia supernova. Because these massive thermonuclear explosions reach roughly the exact same peak brightness when a white dwarf star detonates, observing how bright they appear from Earth allows scientists to estimate how incredibly far away the host galaxy is resting. Finally, for the absolute deepest reaches of the cosmos, astronomers measure the delicate redshift of the galaxy's light. As the vast universe continuously expands, the very fabric of space stretches the ancient light, traveling through it to longer, redder wavelengths. The more distant an object is, the more the universe has expanded since its light was emitted, and the greater its redshift appears to our instruments. By carefully measuring the redshift of light from IC 1101, astronomers have confidently determined that it is roughly 1.04 billion light-years away. It is a profound testament to human curiosity that we, relatively short-lived beings born on a tiny, rocky world, can cast our minds out across billions of years of silence to touch the ancient light of a cosmic giant. Our shared journey of discovery is a beautiful reflection of the universe awakening, opening its eyes, and gently seeking to comprehend its own infinite majesty and scale. I also want to gently talk about what it profoundly means to observe a celestial object that is resting a billion light years away from our curious eyes. When we look through our telescopes at the gentle, fading glow of IC 1101, We are not actually seeing the galaxy as it exists today in the present moment. We are seeing it exactly as it was over 1 billion years ago, in the deep, ancient past, when the delicate photons of light we detect today first began their incredibly long journey toward our Earth. 1 billion years ago, our own vibrant world was a very different, much quieter place. Complex animal life had not yet evolved to walk upon the land or swim in the deep oceans. The planet was primarily populated by simple, single-celled organisms and perhaps the earliest multicellular life, but absolutely nothing that would be recognizable to us as an animal or a plant. The great continents were in entirely different positions, slowly drifting and gathering together in ancient configurations that would be completely unrecognizable on any modern map today. The very atmosphere we breathe had a profoundly different chemical composition, rendering it an alien world by any human measure. During all of the unimaginable time that has quietly passed since then, the ancient light from IC 1101 has been steadily traveling through the freezing, silent space. It crossed the vast, terrifying emptiness between the distant galaxies, occasionally passing like a ghost through invisible clouds of intergalactic gas, or being bent ever so slightly by the immense gravity of intervening cosmic objects. It traveled at the absolute fastest speed that anything in reality can travel. Yet the distance was so profoundly immense that it took over 1 billion years of continuous flight just to arrive here. Over a span of 1 billion years, so much could have profoundly changed in the dark. Ancient stars that were shining brightly back then might have quietly burned out by now, fading into cold remnants. The massive central black hole might have experienced entirely new, violent feeding events, or gone through long, extended periods of absolute dormancy. Smaller galaxies that were actively falling toward IC 1101 1 billion years ago might have been completely consumed and absorbed by now. We have absolutely no way of knowing what IC 1101 looks like at this very moment in time. The true information about its present state will simply not reach our descendants for another 1 billion years. In a very real and profoundly poetic sense, we are all archaeologists of the cosmos, quietly studying the ancient past rather than observing the present. Every single observation of a distant celestial object is a literal look back in time, a precious glimpse of how things used to be in the universe, rather than how they are right now. This unavoidable cosmic time delay is both a frustrating limitation and a beautiful, unique opportunity for our curious minds. It gently limits our absolute understanding of the present, but beautifully allows us to study cosmic history directly by looking at galaxies at different distances. By observing these distant phantoms, our astronomers can carefully piece together exactly how galaxies have changed, grown, and evolved over the immense sweep of cosmic time. We can look into the deep dark and see what galaxies looked like when the universe was incredibly young, carefully compare them to more recent, local examples, and faithfully trace the slow, majestic evolution of cosmic structures over billions of years. IC 1101, seen exactly as it was 1 billion years ago, generously provides a single, breathtaking snapshot of a giant, cannibalistic galaxy in a very particular, quiet stage of its long evolution. Other giant elliptical galaxies, some located closer to us and some located farther away, gently provide additional crucial snapshots for our understanding. By carefully and respectfully combining all of these disparate observations, our astronomers slowly build up a comprehensive, moving picture of how such immense galaxies form, grow, and eventually change over the deep ocean of time. Now, I want to gently talk about something that profoundly fascinates me on a personal level, something that touches the very core of our human experience of wonder. The numbers we have been quietly discussing throughout this journey are so incredibly vast that they naturally become abstract and difficult to hold in the mind. 100 trillion ancient stars, 4 million to 6 million light-years of distance, 1 billion years of silent travel. These are numbers that our human brains, beautifully evolved for a small, rocky planet, handle quite poorly. We are perfectly adapted for counting small groups of things, measuring short distances we can physically walk, and tracking the brief time spans of passing seasons and human generations. Absolutely nothing in our long evolutionary history adequately prepared us for comprehending the true cosmic scale. So, let me gently try a few more mental thought experiments to help make these staggering numbers feel a little more real, a little more grounded in our shared reality. Imagine, if you will, that you deeply wanted to take a single, beautiful photograph of every single individual star in the vastness of IC 1101. You are generously given a very fast, perfect camera that can snap exactly one picture every single second, and you are granted the magic of never needing to rest, sleep, or pause. How long do you think it would take to individually photograph all 100 trillion ancient stars? The staggering answer is over 3 million years of continuous, unbroken photography. If you had started taking these pictures back when the very first early humans evolved on the savannas of Earth, you would still have millions of years of photography lying endlessly ahead of you right now. Or consider this quiet comparison. The tiny, countless grains of sand on all the beaches of our entire Earth number perhaps in the hundreds of trillions. IC 1101 contains roughly as many massive burning stars as there are tiny grains of sand on every single beach on our entire sprawling planet. Each one of those distant stars is a massive nuclear furnace, quietly burning ancient hydrogen into helium, safely releasing energy that streams outward in every possible direction into the dark. Each one might be surrounded by quiet planets. Each one has a long, complex story, an ancient history, and a silent future. Now, imagine trying to take a gentle, peaceful walk entirely across the face of IC 1101. The average human walking speed is about 3 miles per hour. At that steady, unhurried pace, walking 24 hours a day without ever stopping to rest your feet, it would take you about 50 trillion years just to walk from one outer edge of IC 1101 to the far opposite edge. Let that number settle in your mind. 50 trillion years. That is over 3,000 times longer than the current entire age of the known universe. You could peacefully walk for the entire sweeping history of absolutely everything that has ever happened from the explosive Big Bang until this very quiet moment. And you would have covered less than 1/13,000th of the total distance across this single majestic galaxy. Or let us quietly think about the concept of communication across the void. Light is the absolute fastest thing in the entire universe, traveling at an astonishing speed of about 670 million miles per hour. A simple, peaceful message sent by a beam of light from one far side of IC 1101 would still take between 4 million and 6 million years just to reach the other side. If a quiet, advanced civilization living on one remote edge of IC 1101 decided to send a message of greeting to another civilization resting on the opposite edge, the receiving civilization would not get the gentle message for millions of years, and any hopeful reply would take millions of years more to simply return across the dark. Communication across a single immense galaxy like this would span profound geological timescales, making any sort of galactic conversation a supreme exercise in absolute patience. These mental thought experiments do not magically make the massive numbers truly graspable. Frankly, nothing can perfectly do that. The gentle human mind simply is not built for such terrifying cosmic scales. But they can gracefully give us a deep sense of the vastness, a profound feeling of awe in our gut, even if we cannot hold a true, complete understanding in our logical heads. Let me now gently turn our contemplation to a question that might naturally be resting on your mind as we journey through this infinite space. If IC 1101 is so incredibly enormous, so packed with ancient light, are there aliens living there in the dark? Could a single galaxy that contains an unfathomable 100 trillion stars actually be a quiet home to intelligent life? This is exactly the kind of beautiful, profound question that science simply cannot answer directly right now. We currently have absolutely no way of physically detecting life in distant galaxies across the deep void. We barely have the developing technology to look for simple life in our own local solar system, let alone in ancient galaxies resting a billion light years away. But we can quietly, peacefully think about what the staggering numbers strongly suggest to our curiosity. If life fundamentally requires warm, stable planets, and planets naturally orbit around stable stars, then a massive galaxy with vastly more stars should mathematically have far more potential homes for life to emerge. Our own Milky Way might have somewhere between 100 billion and 400 billion planets drifting in the dark. If even a tiny, infinitesimal fraction of those planets are suitable for nurturing life, there could theoretically be millions of worlds with living, breathing things in our galaxy alone. Now, scale that hopeful thought up to the majestic immensity of IC 1101. With 100 trillion ancient stars, this gentle giant could possess hundreds of trillions of wandering planets. Even if only 1 in a billion of those distant planets miraculously developed life, that would still mean hundreds of thousands of living, breathing worlds hidden in the dark. Even if only 1 in a trillion gently developed intelligent life, capable of building quiet, contemplative civilizations, that would still mean 100 complete civilizations residing in IC 1101. Of course, we must humbly acknowledge that these numbers are purely based on assumptions that we cannot currently verify. We simply do not know how wonderfully common life might be in the vast universe. We do not know how frequently life gently develops intelligence and curiosity. We do not even know for absolute certain that life strictly requires rocky planets exactly like ours, or that it demands liquid water, or that it must be based entirely on carbon atoms. The breathtaking diversity of physical conditions in the universe might be perfectly matched by an equally breathtaking diversity of forms that life can miraculously take. What we can confidently say, with a sense of gentle wonder, is that IC 1101 offers an absolutely enormous ancient canvas for whatever mysterious processes might lead to life. A galaxy of that staggering size has been steadily producing burning stars for billions of years. Heavy, complex elements, the essential carbon, oxygen, and iron that living things need to exist, have been relentlessly manufactured in ancient stellar cores and violently scattered through space by supernovas countless times over the eons. Whatever the secret recipe for life might truly be, IC 1101 has possessed vast, unlimited resources and enormous spans of quiet time to cook it up. And if intelligent life does beautifully exist somewhere deep within IC 1101, what might they think when they stand and look up at their own night sky? Their view of the cosmos would be profoundly, wildly different from ours, where we look up and see a relatively sparse, peaceful field of stars with a single, hazy band of the Milky Way stretching across the dark heavens. They would step outside and see burning stars absolutely everywhere, in every conceivable direction. The physical density of ancient stars in an elliptical galaxy, exactly like IC 1101, is much, much higher than in the flat, rotating disk of a spiral galaxy like ours. Near the dense, quiet center of IC 1101, the night sky would be absolutely ablaze with brilliant light. Stars would crowd so incredibly closely together that there might not be any true, deep darkness at all. The combined gentle glow of billions upon billions of nearby stars would effortlessly fill the alien sky with a perpetual golden twilight. Navigation by observing the stars would be virtually impossible, because there would simply be far too many stars to cleanly distinguish one from another. Further out from the dense center, conditions would be a little more like what we gently experience, but still profoundly different. No beautiful, sweeping spiral arms would trace patterns across their sky. No central glowing band of light would mark the flat plane of a galactic disk. Instead, the ancient stars would be gracefully distributed in a more spherical, completely encompassing pattern, completely surrounding any quiet observer in a bright, beautiful shell of stellar light. Would such gentle, distant beings know about the violent, ancient history of their own galaxy? Would they have successfully discovered that their immense home was slowly built from the scattered remains of dozens of smaller galaxies completely consumed over billions of years of silent cannibalism? Would they have developed the technology to detect the enormous, sleeping black hole resting at their galaxy's center? Or figured out that their cosmos was billions of years old? We cannot know the answers to these mysteries, but it is profoundly fascinating and deeply comforting to think that somewhere in the vastness of IC 1101, on one of hundreds of trillions of possible quiet planets, intelligent beings might be looking up and asking the exact same questions about the universe that we gently ask here on Earth. They might be looking out at the surrounding empty space, seeing other tiny galaxy clusters in the far distance, quietly wondering if those distant, faint smudges of light contain other minds like theirs. They might have even detected our tiny Milky Way, though from their distant perspective, it would be just another unremarkable, faint spiral galaxy among billions of others. The universe is vastly beyond our simple comprehension, and the beautiful possibilities it contains are equally, infinitely vast. Every single galaxy we carefully study gently reminds us of this infinite vastness and beautifully challenges us to peacefully think about our humble place within it. Now, I want to gently take you through a timeline of IC 1101's history, as best as our scientists can reconstruct it from careful observations and theoretical models. This majestic timeline spans billions of years and involves processes that are deeply difficult for our minds to imagine. But understanding this ancient chronology helps us profoundly appreciate how this cosmic giant came to be resting in the dark. The story begins roughly 13 billion years ago, not long after the spark of the Big Bang itself. The universe at that time was a very different, deeply quiet place compared to what we see today. There were absolutely no galaxies yet, just vast, endless clouds of primal hydrogen and helium gas, gently left over from the first few fleeting minutes of cosmic history. These ancient clouds were not perfectly uniform. Some regions were slightly denser than others, and the gentle hand of gravity began to slowly pull these denser regions together in the dark. Over the first few 100 million years, these denser regions quietly collapsed to form the very first stars and the first primitive galaxies. These early fragile galaxies were small, irregular collections of stars, looking absolutely nothing like the grand, sweeping spirals and smooth ellipticals we admire today. They formed safely in the densest parts of the cosmic web, the invisible network of dark matter filaments and nodes that gracefully define the large-scale structure of our entire universe. The specific region of space that would eventually become the Abell 2029 cluster was one of these incredibly dense regions. Many small, bright galaxies formed there in the deep past, and they immediately began interacting with each other in the dark. Galactic mergers happened much more frequently in the early crowded universe, when galaxies were physically closer together. One of those early galaxies, or a chaotic merger product of several early galaxies, was the ancient ancestor of IC 1101. We do not know exactly what this early proto-galaxy looked like, but it was probably a chaotic collection of a few billion stars with a rapidly growing black hole at its center. Over the next several billion years, this proto-galaxy experienced merger after violent merger. Each time a wandering galaxy wandered too close, gravity gracefully captured it and eventually absorbed it into the growing mass. Each ancient merger added trillions of new stars and vast oceans of gas, and each merger faithfully fed the central black hole. By about 10 billion years ago, the ancestor of IC 1101 had probably already become a giant elliptical galaxy, having safely experienced dozens of major mergers. The next several billion years saw continued majestic growth, though at a gradually slower pace. The most intense, fiery period of galaxy formation was quietly winding down across the entire universe. Star formation rates were naturally declining as countless galaxies slowly used up their precious gas supplies. Mergers became less frequent as the relentless expansion of the universe slowly carried galaxies farther apart from one another. But IC 1101 was situated in a very special, privileged location. The Abell 2029 cluster had grown and matured, and IC 1101 sat proudly at its gravitational heart. Surrounding galaxies continued to slowly fall toward the cluster center, drawn relentlessly by the enormous combined gravity of all the matter gathered there. And when they finally reached the dense center, they inevitably encountered IC 1101. During this long, quiet period, IC 1101 probably experienced another 20 or 30 major mergers, along with countless minor ones. Each merger quietly added to its mass, stirred up its ancient stars, and fed its already enormous waiting black hole. By about 5 billion years ago, roughly around the time our own sun was just beginning to ignite its nuclear fires, IC 1101 had gracefully grown to something very close to its current magnificent size. It had essentially run completely out of easy prey. What gently remains today is exactly what we currently observe: a dying giant, still enormous, still deeply magnificent, but no longer growing in the dark. Its central black hole is relatively quiet, and it has gracefully reached a steady state, slowly fading as its stars burn out one by one into the cosmic night. But the growth cannot gracefully continue forever. The larger universe surrounding this giant is constantly changing in profound ways. Space itself is constantly expanding and terrifyingly accelerating in its silent expansion. This gentle but relentless acceleration is driven by something our scientists quietly call dark energy, a profound, mysterious force that makes up about 68% of the total energy in the universe. For most of the 20th century, our astronomers naturally assumed that the expansion of the universe was gracefully slowing down due to gravity. But in 1998, two independent teams of dedicated astronomers made a truly shocking discovery by observing distant supernovas. The universe was not slowing down. It was actually speeding up. Distant galaxies were gracefully moving away from us faster than closer ones, and the overall rate of cosmic expansion was accelerating over deep time. Something invisible and powerful was forcefully pushing the universe apart, perfectly counteracting gravity and causing space itself to expand at an ever-increasing rate. This dark energy acts as a kind of cosmic anti-gravity, quietly pushing space apart rather than pulling it together. As space expands faster and faster, distant objects gracefully recede from us at ever-increasing speeds. Eventually, over unimaginable eons, objects will be carried away from us by the expansion of space, much faster than their light can ever travel toward us. When that silent threshold is crossed, they will vanish completely behind an impenetrable cosmic horizon, forever beyond our gentle reach. For IC 1101, this means that its long days of majestic growth through galactic cannibalism are strictly numbered. Eventually, there will simply be absolutely no more galaxies left in the dark for it to gracefully consume. It will become profoundly isolated, a lonely, ancient giant floating in an ever-emptying universe, quietly watching as one by one the other distant galaxies simply fade from view. In about 100 billion years, the silent expansion will have accelerated to the point where galaxies outside the local supercluster will start to completely disappear over the cosmic horizon. The currently observable universe, which wonderfully contains about 2 trillion galaxies, will shrink and shrink until it is almost entirely dark. Within the Abel cluster itself, things will gracefully remain different for a while longer, as gravity holds it together. In the very long run, perhaps in several 100 billion years, all the galaxies in the cluster might gracefully merge into a single enormous galaxy, even larger than IC 1101 is today. By that time, however, the universe beyond the cluster will be essentially completely empty, showing only a backdrop of absolute, unbroken blackness. But even this majestic isolation is not the final fate of IC 1101. Over the next 100 trillion years, the trillions of stars in IC 1101 will slowly, inevitably burn out. The massive, bright blue stars went dark long ago, collapsing into silent black holes. The middle-sized stars, much like our own life-giving sun, will puff up into beautiful red giants, shed their outer layers, and then slowly fade away as cold white dwarfs. Even the absolute smallest, longest-lived stars, the tiny red dwarfs that burn their precious fuel so incredibly slowly they can shine for trillions of years, will eventually exhaust their hydrogen and go dark. Scientists estimate that all star formation in the universe will effectively cease entirely in about 100 trillion years. By that deeply distant time, the gas and dust needed to make new stars will have been completely used up. The beautiful era of starlight will be permanently over. one by one, the 100 trillion stars of IC 1101 will simply wink out. The galaxy will grow dimmer over timescales that make the current age of the universe seem like a brief blink of an eye. Where once there was a blinding blaze of stellar light, there will eventually be nothing but the cold, dark remnants of dead stars drifting endlessly through an ever-cooling void. The universe at this profoundly late stage will be a deeply dark and quiet place, but we must understand that it will not be an entirely empty one. All of those ancient stellar remnants, the quietly cooling white dwarfs, the unimaginably dense neutron stars, and the silent black holes will still safely exist in the freezing void. They will gracefully continue to orbit through the dark, merged remnant of what was once the glorious IC 1101 and its many cluster companions. The entire galaxy will become a quiet ghost of its former vibrant self, populated entirely by the cold corpses of ancient stars rather than by living, burning suns. But even this profound silence is not the final, ultimate end of the cosmic story. Over even longer, majestic time scales, measured in years with so many zeros that simply writing them out would fill countless pages, even these resilient stellar corpses will inevitably decay in the dark. White dwarfs will slowly, gently cool until they become theoretical black dwarfs, objects that no longer emit any light or heat at all. This gentle cooling process takes an almost inconceivable amount of deep time. A single white dwarf cools to near absolute zero only after about 10 to the 15th power years, or about 1,000,000 billion years of silent waiting. That staggering number is roughly 100,000 times longer than the current total age of the universe. Neutron stars might gracefully decay as their fundamental particles gradually break down over the sweeping eons. We are not entirely perfectly sure about this specific process because it gracefully depends on whether protons, the fundamental building blocks of atomic nuclei, are truly stable, or whether they eventually decay in the infinite dark. Some profound theories of particle physics carefully predict that protons should decay with a half-life of around 10 to the 34th power years, or perhaps even longer. If this profound theory is true, then over unfathomably long, quiet time spans, even the very matter that makes up neutron stars, white dwarfs, wandering planets, and absolutely everything else will gradually, peacefully dissolve into a gentle sea of radiation. And what of the black holes, including that enormous sleeping monster resting at the ancient heart of IC 1101? They will slowly, inevitably evaporate through a beautiful quantum process called Hawking radiation. The brilliant physicist Stephen Hawking famously discovered that black holes are not truly perfectly black. They slowly leak delicate particles and faint radiation over immense sweeping time spans, gradually shrinking as they gracefully do so. This gentle evaporation happens because of strange quantum mechanical effects constantly occurring near the terrifying event horizon. In the bizarre microscopic world of quantum physics, fragile particle pairs are constantly popping into brief existence and then immediately annihilating each other. Near a black hole's event horizon, one member of such a delicate pair can gently fall into the black hole, while the other escapes into the vast space. Over unimaginable stretches of time, this slow process gently drains energy from the black hole, causing it to quietly shrink in the dark. The exact rate of Hawking radiation is incredibly, agonizingly slow for large black holes. A black hole, with the mass of our life-giving sun, would take about 10 to the 67th power years to completely evaporate. That is, a 1 gracefully followed by 67 zeros. But the supermassive black hole at the center of IC 1101 is billions of times more massive than our Sun, and the time for it to evaporate is correspondingly terrifyingly longer. A black hole containing 50 billion solar masses would take something like 10 to the 100th power years to fully evaporate, or maybe even longer. That immense, staggering number is called a googol years, a 1 followed by 100 zeros. To write out that staggering number in full would require more paper than currently exists on our entire Earth. It is a span of quiet time so incredibly vast that absolutely everything we have discussed so far, from the explosive Big Bang to the gentle death of the last stars, is not even a rounding error by comparison. But even this incomprehensible span of time is not strictly infinite. Eventually, trillions upon trillions upon trillions of years from now, even the supermassive black hole at the ancient heart of IC 1101 will have gently radiated away its very last bit of energy and quietly disappeared from the universe in a final, gentle burst of Hawking radiation. When that deeply distant moment finally happens, there will be absolutely nothing left of IC 1101 at all. No ancient stars, no silent black holes, no physical remnants of any kind, just the scattered particles and thin radiation that once proudly made up a galaxy, spreading out indefinitely through an ever-expanding, ever-cooling, ever-darkening universe. The absolute largest galaxy we have ever found will have faithfully followed the same ultimate path as every other structure in the cosmos, gracefully dissolving into the endless night. This grand vision of the deep future might seem terribly bleak to some, but I find something strangely beautiful and deeply comforting about it. IC 1101 beautifully exists right now in this incredibly brief, precious moment of cosmic history when stars still shine brightly and galaxies still glow with warmth. It has gracefully existed for billions of years and will gently continue to exist for billions more in the grand sweep of cosmic time. The beautiful era of stars and galaxies is just a passing phase, a brief, magnificent flowering of complexity delicately positioned between the chaos of the early universe and the cold emptiness of the far future. We are incredibly lucky to peacefully exist during this rare flowering. We are profoundly lucky to have gently evolved intelligence, built sensitive telescopes, and pointed them toward the quiet sky. We are lucky enough to have discovered IC 1101 and to intimately understand, at least in part, what it is and exactly how it came to be. In all the vast, sweeping history of the universe, stretching from the initial Big Bang to the final, quiet heat death, this very moment right now is profoundly special. It is the unique moment when the universe has beautifully developed the ability to look at itself and feel wonder. And what we clearly see when we look at IC 1101 is the absolute grandest scale on which the universe has ever assembled matter into beautifully organized structures. We see billions of years of cosmic history written elegantly in the light of stars. We see the gentle results of countless galactic mergers, countless slow collisions, countless acts of gravitational violence that have somehow miraculously produced something magnificent. We see a gentle monster, yes, but also a magnificent monument, a silent monument to the fundamental forces that shape our universe and to the delicate processes that have been building complexity ever since the first atoms formed. Let me gently bring us back closer to our planetary home for a quiet moment. Our own Milky Way is not completely immune to the exact same forces that beautifully shaped IC 1101. We too are actively participating in the eternal cosmic dance of galactic interaction and gentle merger. Right now, our peaceful galaxy is in the slow process of consuming several smaller dwarf galaxies. The Canis Major dwarf galaxy is being gracefully ripped apart and absorbed into the Milky Way, while the Sagittarius dwarf galaxy is being stretched and beautifully distorted by our gravitational pull. And in the deep future, an even more dramatic event quietly awaits our distant descendants. The Andromeda galaxy, our nearest large neighbor, is slowly heading toward us in the dark. Scientists have long believed that in about 4 to 5 billion years, the Milky Way and Andromeda might collide and eventually merge into a single larger galaxy, often affectionately nicknamed Milkomeda. Whether it gently happens in 4 billion years, 10 billion years, or not at all, the process itself beautifully illustrates the exact same forces that patiently created IC 1101. Galaxies interact, merge, and peacefully consume each other. It is the natural way of the universe. What does the existence of IC 1101 truly tell us about our humble place in the infinite universe? When you look up at the night sky, you might naturally feel incredibly small. You might feel profoundly insignificant in the face of such absolute vastness. But I think the very existence of IC 1101 actually tells us something deeply hopeful about our situation. First, gently consider that we can know about IC 1101 at all. A massive galaxy more than 1 billion light-years away, containing 100 trillion stars, and we have elegantly figured out how big it is, how it formed, and what dark entity safely lies at its center. That is utterly remarkable. Human beings living on a small, rocky planet orbiting an ordinary star in an unremarkable part of an average spiral galaxy have somehow developed the profound ability to understand objects so far away that their light left before a complex life existed on Earth. This gentle ability to understand is not nothing. In a universe of mindless matter and energy, of particles bouncing around according to physical laws, somehow here on Earth, consciousness has beautifully emerged. Minds that can wonder, question, investigate, and playfully learn. Whatever else we truly are, we are the part of the universe that has peacefully woken up and started asking beautiful questions about itself. Second, deeply consider that IC 1101, for all its terrifying enormity, is fundamentally made of the exact same stuff we are. The stars in IC 1101 are fusion reactors just like our Sun, burning hydrogen into helium and heavier elements. As the great Carl Sagan so beautifully articulated, we are made of star stuff. The atoms in those distant ancient stars are the very same kinds of atoms that gently make up our fragile bodies. The carbon, the oxygen, the nitrogen, the iron. All of them were beautifully forged in the hearts of stars somewhere in the universe. Just as the atoms in our bodies were forged in stars that exploded before our sun was born, there is a profound continuity here, a deep connection between us and absolutely everything else in the cosmos. We are not completely separate from the universe. We are intimately part of it. The exact same physical processes that patiently built IC 1101 also carefully built us. The very same ancient atoms that quietly shine in distant galaxies now shine brightly in our eyes. We are not merely passive observers of the universe from the outside. We are the magnificent universe observing itself from within. Third, quietly consider what it means that galaxies like IC 1101 can exist at all. The universe did not absolutely have to be this way. If the fundamental constants of physics were slightly different, if gravity were a little stronger, or the nuclear forces a little weaker, stars and galaxies might never have formed. The universe might have quickly collapsed back on itself moments after the Big Bang, or expanded so impossibly fast that matter never clumped together. Instead, we proudly live in a universe where physical laws beautifully allow for the formation of stars, planets, galaxies, life, and mind. IC 1101 is a magnificent testament to what is possible in such a universe. It is ultimate proof that matter and energy, following simple physical rules over billions of years, can quietly organize itself into structures of staggering complexity and beauty. Every new discovery we peacefully make, every galaxy we respectfully study, absolutely every black hole we observe, gracefully expands our sense of what is truly possible. A few centuries ago, people firmly thought Earth was the center of everything. Then we learned that we softly orbit the sun. Then we learned that the sun is one star among hundreds of billions in our galaxy. Then we learned that our galaxy is just one of trillions. Each step has made us smaller in some sense, but it has also made the universe grander, more deeply interesting, and more worthy of awe. IC 1101 is another profound step in that journey. It gently shows us that the universe can patiently build things far larger than we ever possibly imagined. It beautifully challenges us to keep asking questions, to keep looking further into the dark, to keep gently pushing the boundaries of what we know. In the silent face of IC 1101's incomprehensible enormity, we can choose to feel small, or we can choose to feel a profound, respectful wonder. I deeply invite you to choose wonder. As we gracefully wrap up this exploration of the biggest galaxy ever discovered, I want to leave you with one final, peaceful image. Imagine yourself floating safely in space, somewhere near the very edge of IC 1101. Around you, in absolutely every direction, ancient stars stretch out toward infinity. Not hundreds, not thousands, not millions, but trillions of stars. Each one is a burning sun. Each one might have quiet planets. Each one has been shining for billions of years. You cannot see the dense center of the galaxy from here. It is too far away, hidden beautifully behind countless curtains of stars. You cannot see the absolute edge either, because the galaxy fades gradually into the darkness of intergalactic space with no clear boundary. You are lost in a peaceful sea of light, completely adrift in a structure so vast that crossing it would take millions of times longer than human civilization has even existed. And yet, from a small, rocky planet more than 1 billion light-years away, beings who live for less than a cosmic instant have beautifully figured out that this place exists. They have successfully measured its size, counted its stars, and found the sleeping black hole at its heart. They have gracefully traced its history back billions of years and projected its future trillions of years hence. They have placed it in the context of an entire universe and marveled at its grandeur. That is perhaps the most deeply amazing thing of all. Not that IC 1101 simply exists, but that we, brief sparks of consciousness, intimately know it does. Thank you for beautifully joining me on this quiet journey through the biggest galaxy ever discovered. If this peaceful exploration helped you gently see the universe in a new way, please consider gracefully leaving a comment, letting us know what you deeply think about our humble place in a cosmos that contains such magnificent wonders. We are a quiet community of explorers, navigating the deep mysteries together in the dark. And if you truly want to keep exploring the deep mysteries of the universe with us, do not forget to gently like this video and peacefully subscribe to the channel. The journey of discovery is infinite, and we have only just begun to chart the quiet shores of the cosmic ocean. Until next time, my friends, please keep looking up into the dark, find peace in the stillness, and always keep wondering.